Okay, so after video 28, if anybody looks back at video 28, we left off at 2.4. 2.4 is just about, chapter 2 is just about done. I know that I kind of discuss a lot. We finished the homework after video 28, and then we kind of looked at some notes and all of that, my own solutions guide to chapter 3, 4, and 5. We are doing chapter 3. I just forgot that technically we left off at 2.4, so we just want to quick do one video on elasticity here. So we left off at 2.4 before we completed the homework. Before the homework was video 28, and then we went on from there, and now we're picking up where we left off from there. But this is elasticity. The first paragraph just basically introduces elasticity right here, and then 2.6 is the major equation. It comes back in chapter 5, elasticity. We have the equation in a lot of places. It looks different, but it's the exact same equation. So elasticity only comes in this one equation, 2.6. Yeah. We don't really do a derivation for it in this book. So we do a brief description, but for the most part right now, we don't have to understand exactly where the thing comes from, just that it's the percent change in y given a percent change in x. So let's kind of proceed here. So like we said, they do that there. What was it saying right there? However, there are at least one important drawback when looking at the derivative. The units of measure used in our variables affect the size of the derivative. I think that's kind of ambiguous here. We just want to know the basic definition. We can always kind of read back through this. It's just an introduction. It's not so important. To get around this problem, economists often use the notion of elasticity to measure the responsiveness of a dependent variable y to a change in independent variable x. Uh, Elasticity measures the percent change in y caused by the percent change in x. It's always better to just kind of, straight up say the definition and understand it instead of talk about that background. But out of the whole chapter, that one thing there and the equation, those are the two most important, the whole section, I mean 2.4 that we're in. So if somebody just says, what is elasticity? They're going to say in a minute, technically this equation is called point elasticity. But when we say elasticity, we're talking about point elasticity. The percent change in y, yeah, the percent change in the vertical caused by a percent change in x, the horizontal, but it will always be later multivariable functions, as we know. And it uses the slope, which means it is an approximate change, but still very, very effective there. So it isn't the change, they measure it that way. Its elasticity it's important to understand that it's the percent change in y. It's not the change in y with the change of in x. That's going to be very easy to just forget the easiest idea. The derivative, all derivatives are basically a what? Uh, Apologies. How can we forget the simplest concept here? Yes. So I was just kind of looking. I don't know why I just couldn't say marginal for a second. I totally forgot to say marginal, but a marginal change is a derivative. They're not kind of, it is an approximation, but remember, basically in microeconomics, the derivative and the word marginal basically mean the same thing. And that's what marginal is. Marginal is the marginal change in y with the change in x. So it's a different concept with elasticity is the percent change in y caused by the percent change in x. By looking at the percent change in both x and y, elasticity becomes a unit-free measure that can be, yeah, the marginal, the first derivative is not unitless, but the elasticity is defined as unitless. It is a unitless measure. Um, so by looking at the percent changes in both x and y, elasticity becomes a unit-free measure that can be readily interpreted and applied to many different markets. Given a function y equals f of x, the elasticity of y with respect to x is given by, and that is the point elasticity equation for the entire book. Yes, it has, of course, a multivariable form, but it's basically exactly the same. And we don't need this. I mean, what do you do? It should be pretty obvious here, yes. So you take the derivative. Yeah, we have a function f of x. Yes, d over dx. F of x is just the Leibniz notation for the first derivative. Literally take that and multiply it by x and divide by the original function, and that's going to be what the elasticity is. It's called plug and chug. Whenever you just have an example and you just have to basically plug into an equation, it should be very easy. But they have an example there, so we don't really have to do that. They're just going to introduce the basic chart. So let me just kind of show you where we're going, because I know that I ramble a lot, like a 10-minute video on the easiest thing, but there's two things that are very important, or maybe three. One was the definition we just did, percent change in y, given a percent change in x, that's what it is. Two is then the equation, yeah. And three, I don't recall if we showed it in a previous video, we might have, or something, because I showed things a little bit out of order here. But all of it is really just building up to this one chart. After this chart, we immediately get into chapter 3. So 2.4 and all of chapter 2 is concluded with this one chart. Yes. So they might have a line of reasoning why, but it's going to be like this. Unit elasticity means literally a 1% change in x is going to change y by 1%. So if what is elasticity? It's the percent change in y given a percent change in x. If that number is less than one, it's considered inelastic. Yeah, inelastic is just meaning that it doesn't change much with a kind of a small or fairly big change in x. The y doesn't change much. Yeah, all of the changes in x's are actually considered fairly small. But inelastic, relatively inelastic would mean the value is less than one, would obviously just mean that y doesn't change very much given a change in x. Okay, so elastic, yeah, elastic would obviously be greater than one, and that just means that there is some sort of significant change in y. Yeah, a percentage, what is it? If it's like 1% over 1%, yeah, greater, yes. So this thing is greater than one would just mean that we have greater than a 1% change, yeah. Another way to look at it, greater than a 1% change in y given a 1% change in x. Yeah. Less than a 1% change in y given a 1% change in x. And if they're equal, then obviously unit elasticity. So that's kind of the main part. You don't really get this so much in real life. If x is changing a lot and y doesn't change at all, it's called perfectly inelastic. Yeah. If you change x just a little bit and y skyrockets, then perfectly elastic. So we have concepts like that. Uh, it's just basically that. So we're going to end the video soon, but I don't just want to fly through this too much. They explain all of that. It's not so much a derivation, it's just an example. So they kind of give you some example cases if we just scroll through this. There, the equation 2.6, they're just saying that technically it is point elasticity. A concept like arc elasticity is for a different class. It doesn't have to do with this class. We just use the very basic thing. And they're just giving a quick introduction to the table that we just showed there. We just have to basically know the outcome. Okay, so that is officially it. And, I've said it probably 10 times over videos, but now we are going to jump into chapter 3 immediately with the next video. So we'll see you guys in chapter 3.